Class is differentiation. Now we want to know how to differentiate a function using first principle. So now, for example, we have a function y equals to 2x. Now we have a law, which is our power law, where we can just multiply the power of the variable x by the coefficient of x, which is 2, and reduce it by 1. So now if we want to use the power law here, it will be what? 2 raised to power x. It will be 2 times 1 x raised to power 1 minus 1. Why is it so? Because x is raised to power 1, and now we are reducing it to what? 1, right? So this will give us 2x raised to power 1 minus 1 will give you 0. And in our law of indices, anything raised to power 0 is what? 1. So it will give you what? 2. But now, this is a simpler way, but now we want to know how to use what? First principle to solve this particular problem. Please, let's do that. We have y equals to 2x, and I want to use first principle to solve this particular problem to get the answer, right? Now what do? Differentiation is just change in what? X, change in y, which affects what? Change in x, right? Because y is what? The dependent variable, and x is what? The independent variable. So whatever affects x affects y. So we now write y plus change in y will be equals to what? 2 into x plus change in x. This is it. So now we are looking for what? The derivative. The derivative of every function is the change in that particular function. That's what we are looking for. So now when you take y, change in y, this will now give you 2 into what? X plus change in x. Now, which will give us minus y. Now we transfer y to this other side of the equation by what? Subtracting y from both sides of the equation. When you subtract y from this side, to give you 0, right? And when it comes this way, to be minus y. So here we have our change in y equals to what? When you multiply inside the bracket, you have what? 2x plus 2 change in x minus y. And now y is actually this. Y is 2x. Y is equal to 2x. So we write our what? 2x. So now when you collect like terms, we have change in y equals to what? 2x minus 2x is to give you 0. So we have what? 2 change in x. And now we are looking for change in y, which affects change in x. So we divide both sides by what? Change in x. So we divide both sides by change in x. And now our change in y all over change in x will equals to 2, which is also our dy dx. Thank you for that. Now also, we also do a particular problem again. Now, assuming we have something like this, x, y equals to sine x, y. Now, looking at this kind of problem, how do we solve something like this? Now, if you see, this is a combination of different laws of differentiation. We have what? The product rule here. We have the function or function rule. We have the trig function here, and we also have what? Product rule here. So we need to apply all of those rules bit by bit. So on the left hand side, we have the product rule, and the product rule here is what? Our u, it's equal to what? X. Now our du will give you what? Will give you 1. Because when you differentiate x using our power law that we said, when you differentiate x, you give you what? 1. Now our v, it's y. Then our dv, it will give you dy dx. Now why do we get dy dx? Is because y is what? A dependent variable. So y cannot be expressed in its own term. It must be anything. If you want to differentiate y, it must be in terms of x, because it depends on what? X. So now for the left hand side, let's apply our product rule, which is u dv dx plus v du dx. Now what's our u? We have our x, right? Our dv is what? Dy dx plus what's our v? Our v is y, and our du dx is 1. So now this will give you x dy dx plus y. Now this is for the left hand side of the equation, right? This is for the left hand side of the equation. Now let's proceed to the right hand side of the equation. Now this is a trig function and it's also a function of function. Now a function of function, it's you use the core function here is x and y. Xy is the core function and sine is what? The normal function, and which this core function, this other function cannot function without the core function, right? So now we now initialize u to be x, y. So now sine u will give us what? Cos u. When you differentiate cos sine u, you will get cos u. So this now gives us cos u, and now we now do our normal differentiation here also, because this is actually a product rule. Are we together? Now this is actually a product rule. Now our u, as we've gotten our cos u, we now say our x. Yes, let me write this way. Y dx plus y. Okay. So now we're differentiating our u also. So what's our u? Yeah, our u is x, y, and this is also our product rule. If you look at the left hand side, we had x and y, and so won't go through all the whole process of doing the whole product rule any longer. We'll just implement it here. So we now say this will give us cos u times x dy dx plus y. Now our u is x. Our u is what? Xy, which is times x dy plus y. Now this on the left hand side is x dy dx plus y, which is equals to cos into xy times x dy. Okay, let's just write it instead of for space. This will now give us x dy dx cos xy plus our y cos xy. Now we are going to collect like terms. Anyone that has dy dx will come on another side, and that's how we're going to do it. So now the dy dx here, we have this, right? We have x dy dx coming to this side to be what? Minus x dy dx cos xy. Now this will go to the other side. It will be equals to y minus, okay, y cos, cos y for this one. Then this y crossing to this other side to be minus y. Let's proceed. Now, looking here, we're collecting like terms, right? So our dy dx will now give us x minus x cos into xy, right? Equal to y cos x y equals to y cos xy minus y. Now you divide both sides by this, it will now give you dy dx, which will give you y cos into xy minus y all over x minus x cos into x y. Now, this can be your final answer for your implicit differentiation. Thank you. Okay, so I'll also be leaving you guys with an assignment on this. Thank you.
Quiz.